Now that you've built and run a few stateflow charts, perhaps you're wondering, when do stateflow charts move between states and transitions, and how does that relate to Simulink? Well, when you have a stateflow chart in Simulink, Simulink manages the chart execution. Recall that Simulink has an underlying sample time, the time interval over which Simulink's numerical solver takes steps. By default, stateflow charts inherit their sample time from Simulink. In this case, every time the Simulink solver takes a step, the chart will take a step. However, the sample time can also be explicitly set in the Chart Properties dialog. For example, you might set the chart sample time to match the desired application rate for your hardware. When a stateflow chart runs, it executes once at each chart time step. But what exactly does execute mean? During execution, stateflow essentially does one of two things: take a valid transition or remain in the current state. Stateflow also performs the appropriate actions for each case: exit and entry actions if there's a valid transition, and during actions if it remains in the state. Once the chart has either entered a new state or decided that it can't, execution is complete for that time step. Let's use this sample chart to look at a few examples of what can occur in one time step. First, what if there's no active state? Well, valid transitions include the default transition. So stateflow follows the default transition and enters state A. Since the chart has entered a new state, execution is complete for this time step. Now the chart is starting in state A. Let's assume x equals 5. When the chart executes at this time step, the transitions are tested in their execution order. Stateflow tests the first transition, but it's not valid, so it tests the second transition, which is valid. Since stateflow has found a valid transition, it transitions to state C. The exit action for state A executes, so Y is set to 1. And now chart execution is complete for this time step. Let's go back and start in state A again, but now let's assume x equals 7. This time, the first transition is valid, so stateflow follows that one without needing to test the second transition. The state actions are executed in order. First, Y is set to 1 when exiting state A, then Y is set to 7 when entering state B. And once again, chart execution is complete for this time step. So even though x equals 7 and it looks like we could take this transition, we don't return to state A at this time step. Finally, what if there are no valid transitions? State A is again active, but now x equals 0 and y equals 1. Both transitions are tested, but neither is valid. In this case, the chart remains in state A. The during action is executed because no transition took place during this time step, and chart execution is complete. Note that the during action will execute for every time step that the chart remains in the state. Okay, let's step through the execution of the useless machine to see a stateflow chart in action. The first time step occurs at t equals 0. Stateflow follows the default transition and enters the turn on state. The state entry action sets voltage to 1, which starts the motor turning towards the on button. Over the next several time steps, the motor is still turning, so button pressed is still 0. Since there are no valid transitions, stateflow remains in the turn on state. Eventually, the motor has turned far enough to turn the machine on. At this time step, the transition is valid, so stateflow takes this transition and enters the turn off state. The state entry action is executed and voltage is set to -1. This turns the motor back the other direction. And the process repeats until the simulation reaches its stop time. Now you know the basic rules for running a stateflow chart in Simulink. As charts become more complex, for example, if you add hierarchy, other rules apply. To learn more about these rules, you can explore the chart execution section of the documentation.